homework solution 2.2. The red waveform below represents current through an inductor, while the blue waveform represents voltage across a capacitor. Annotate the figures so that they both include current and voltage, and indicate the phase shift in each. Identify if each circuit is in phase, lagging, or leading. So for this problem statement, the given information is just those diagrams. There's nothing else, so I'm not going to redraw those. What are we asked to find? Well, we were given current through an inductor here, so we want to find voltage through the inductor. We want to know what the phase shift in that inductive circuit is between voltage and current. And then we want to repeat that exercise for this voltage waveform, so that means we need to find current through a capacitor, and again the phase shift in a capacitor. We also want to determine if those are lagging or leading or in phase circuits. So that's what we're asked to find. I don't know why this thing keeps thinking my finger is a cursor today. Anyway, the solution to this problem is, we'll just identify that since that's an inductor, the circuit is going to look like this. And we know that the mnemonic we typically use to determine the voltage and current relationship in an inductive circuit like this is Eli. We know that the voltage leads the current by 90 degrees. Now this is a plot of current, which means the voltage is going to peak 90 degrees before the current does. So remember, from here to here is 180 degrees. That means this here is a quarter cycle. So this thing needs to be peaking a quarter cycle ahead of this, so that's just right there. That's a peak. When the current peaks, the voltage needs to reach a minimum. When the current reaches crosses the zero axis, the voltage needs to reach its negative peak value, and that behavior is going to repeat. We get a 0 in the voltage whenever the current has a peak either positive or negative, and then whenever there's a current crossing in the 0, we either get a negative peak or positive peak in the voltage. So our voltage waveform is going to look like that. Not a great sine wave that I've drawn there. There's a little bit of lag in my computer today. But anyway, so that's the voltage waveform drawn in blue there. The phase shift in this circuit is, it's not stated explicitly in Eli, but you should know that's 90 degrees. That means the distance from that peak to that peak right there is 90 degrees, or pi over 4. Sorry, pi over 2. Not pi over 4. Pi over 2 is 90 degrees. We also have to determine whether that's a lagging or leading circuit, and we know that that refers to the relationship of current to the voltage, and so this is a lagging circuit. Current is lagging the voltage. Moving on to the capacitive circuit, we can draw a similar circuit for a capacitor. So that's the circuit we're going to be analyzing here. We know that the mnemonic for a capacitive circuit is ICE, and that is also a 90 degrees of phase shift. We'll jump the gun a little bit. We know that current leads voltage in a capacitor, so this is a leading circuit. Current peaks 90 degrees before voltage, so this is a voltage waveform. That means the current's going to peak 90 degrees before it. Again, that's pi over 2 radians. So your plot's going to look something like this. You can see I'm just locating peaks at zero crossings and zero crossings at peaks. need to indicate that phase shift again. Sorry, I scrolled down a little prematurely there. So that distance between right there and right there is 90 degrees in a purely capacitive circuit in which the current leads the voltage.